Hello, this is Mr. Molo talking about lessons 1-2 and 1-3 for your first 7th grade lesson. Some of this is going to be review, but some of it's going to be some review mixed in with some new parts, so just getting a step more difficult. The first part we need to go over is some properties. So we have the additive identity property as our first property, and that just means that our identity that doesn't change, and since it has the word additive, we know we're adding to not change the property. So that means we're going to be adding 0. So you see the example, 3 plus 0 is still 3. It doesn't change our original number of 3. Negative 7 plus 0 is negative 7. Doesn't change our original number. Then there's the multiplicative identity. So the same thing, we're not changing the number. So that means since it's multiplicative, we are multiplying by 1. So any of these examples, 7 times 1 is 7. Negative 14 times 1 is still negative 14. We're not really changing the answer because it's just the identity. It's not going to change. Next property is the multiplicative property of 0, which means anything times 0 is 0. So we have our examples here. 1 times 0 is 0. Negative 8 times 0 is 0. 1/4 times 0 is 0. So just saying what it is of 0. On the homework, yes, you are going to need to know the additive or multiplicative. You just can't say identity property. Then we got some more over here. So the inverse property. Remember, inverse just means flipped around. So if you multiply 1/2, well, the inverse of 1 over 2 is 2 over 1. And whenever you multiply two inverses, you're always going to get 1. Second example, we have negative 4 over 1. Well, the opposite of negative 4 over 1 is negative 1 over 4. And again, if we multiply them, we get 1. Reflexive property is kind of like the commutative property, just saying backwards. That 3 equals 3, negative 1/2 equals negative 1/2, and negative 75 equals negative 75. And then the symmetric property is just a mirror image, so basically just saying the same thing backwards. 3 plus 5 equals 8, 8 equals 3 plus 5. Then we get on to some other examples. So our like terms, and remember we did this in 6th grade. So remember we can only add something if they are exactly alike, if they have the same variable. So I have this 3x and negative 7x. Well, they are like terms. I can add them together and get negative 4x. Our second one, I have a 6w and an 8y. One's a w, one's a y. I cannot add them together, so they are unlike terms. I would just leave it separate as 6y and 8w. This next one are like terms. I have y squared, y squared, y squared, and then there's just the numbers in front of it. So 8y plus 10y minus 3y would give me a 7y squared. These are all numbers, so they all like terms. I can add all those up and get 194. They're like terms. Here I have a 4x and a 4x squared, so even though the 4 is the same and the x is the same, they're not going to be like terms because one is an x squared and one is an x. So I would just leave them separately at 4x and 4x squared. And this last one, I have a 5 and an 8x. They are unlike terms. One's a 5, one's an 8x. They are not the same. All right, and then we have another set of problems where I'm going to be substituting in some problems here. So I have, in parentheses, I have 2 plus g. So doing order of operations, I could see over here that g equals 4. Well, instead of saying 2 plus g then, I'm going to say 2 plus 4. So I'm going to have that in parentheses, and we know 2 plus 4 is going to be 6. So I still have that 3 on the outside. And then I have the plus 5g, which is really going to be 5 times 4, which is going to be 20. So I'm just going to write the 20 out here now. So I have 2 plus 4 is 6. 6 times 3 is 18. 18 plus 20 is going to give me 38. So I can just say my answer for this is 38. Just plugging in all of the numbers that I know in the equation. So kind of the same thing here. I would say negative 2 times x minus 4. Well, I can see over here that x is negative 3. I would say negative 3 minus 4 is negative 7. Plug it in and figure out what my answer is. I have another example over here of the same thing. So I have x is negative 5. So anytime I see an x in my equation, I'm going to plug in a negative 5. So I have 7x minus 5 plus 2. Well, instead of saying 7x, I'm going to say 7 times 5. So 7 times 5 is 35. Minus 5 plus 2. 35 minus 5 is 30. 30 plus 2 is 32. Same thing here. I have x equals 3 and y equals 6. And I'm plugging in for 2x minus 3y plus 7. So if I plug it in, I know my x is 3, so instead of saying 2x, I'm going to say 2 times 3. I know y is 6, so instead of saying 3y, I'm going to say 3 times 6. And I'm just going to go down the line and solve my problem. So I have 2 times 3 first, which is 6. 3 times 6 is 18, so I'm left with 6 minus 18 plus 7. So 6 minus 18 is negative 12. Negative 12 plus 7 gives me negative 5. And then you see that this is a two-part homework, so we also have some absolute value work to do. Remember, absolute value cannot be negative. It is just your distance away from 0. So negative 10 and 10 are both 10 spots away from 0. So you could say your answer is negative 10 or 10 if it's asking how many spots away from 0 it is. So just reviewing some absolute value with the magic tunnel. I know how much you guys like this. So the absolute value of 12 is still 12. It's not going to change. Absolute value of negative 15 is 15. It's distance. It can't be negative. Absolute value of negative 2.5 is positive 2.5. Something like this where it gives you a math problem inside the absolute value. You're just going to solve the math problem. So 2 minus 5 is negative 3. But then you're going to take the absolute value of negative 3 and get positive 3. 3 plus 7 is 10. Absolute value of 10 is still 10. Negative 2 minus 9 is negative 11. The absolute value of negative 11 is positive 11. Then kind of doing the same thing to solve some problems over here. So absolute value of 2 is 2 minus the absolute value of 2, which is still 2. So 2 minus 2 is 0. 16 minus 2 is 14. Absolute value of 14 is still 14. I'm going down. Let's find a negative 1. So here I have negative 16. So the absolute value of negative 16 is 16 minus the absolute value of 8 plus 3, which is 11. So 16 minus 11 gives us 5. So same thing as just a normal addition problem, except you have the absolute value thrown in there. Here I have x minus 6 equals 2, but I have these absolute value bars. There's always going to be two answers when I have an absolute value equation. Okay, so you have to make sure on your homework you're always giving me two answers. And the way I figure out my two answers is I'm going to do two problems. So I'm going to leave one like this, where I'm going to leave x minus 6 equals 2. Well, I see that's x minus 6, so I'm going to add 6 to both sides. So I add 6 to one side, add 6 to the other side, and 6 plus 2 is 8. So one of my answers is going to be 8. So I got my 8 down here. Okay, and the way I find my other answer is rewrite my whole equation. So I'm going to have absolute value of x minus 6, but instead of it being equaling a positive 2 now, I'm going to have it equal a negative 2. And that'll give me my other answer. So again, my same work. It says minus 6. I'm going to add 6. I'm going to add 6 to the other side as well. So I get negative 2 plus 6, which equals 4. So my two answers for this problem are going to be 8 and 4. I can always go back and check it. So if I plug in a 4 here, well, 4 minus 6 is negative 2. The absolute value of negative 2 is 2. Yes, that works. If I plug in my 8, 8 minus 6 is 2. Absolute value of 2 is 2. So that works as well. All right, I will see you all tomorrow.